All right, we're going to talk about the topic of subscripted variables. And to lead into this, let's take a look at something that we've already had. Now in the pink there, I've got a system of equations. And what are the only two ways that I can solve for x and y in a system of equations? We can use substitution, or we could use elimination. And we're still going to continue doing that. Now the difference is what we're going to use for letters or variables. Now notice that in my top equation I have 5x plus 10y equals 125, and in the bottom equation I have x plus y equals 16. Now suppose we're talking about money. Suppose that I have a certain amount of coins. Say that I know that I have nickels and dimes, and I know that something I know with this is that I know that I have 125 cents, worth of these coins of nickels and dimes. I know that I have 16 coins that give me 125 cents. What I don't know is how many nickels I have and how many dimes. So maybe these two equations could relate to that. So in other words, a nickel's worth 5 cents, right? And a dime's worth 10 cents. So I could take maybe this first equation, and what it's representing is if I take the number of nickels I have times 5, that gives me how many cents in nickels I have. And if I take the number of dimes I have times 10, that's how many cents in dimes I have. And this equation is saying that these add up to 125 cents. Now in the bottom equation, my nickels plus my dimes give me the total coins. I have 16 coins that give me 125 cents. Now the problem with this system of equations is the letters or the variables really aren't too meaningful, because if we're using a lot of equations, I want to make them meaningful so I can say, oh yeah, this is what this equation is representing. So another way we could represent these equations is to use subscripted variables. So instead of using x for nickels, maybe I could use this thing called a subscripted variable. And all a subscripted variable is I have a smaller letter in the bottom right. That's called a subscript. It's not an exponent because an exponent's in the top right. So I could let NN represent the number of nickels. So I could say 5 times the number of nickels plus 10 times the number of dimes gives me 125 cents. And then my other equation would be the number of nickels plus the number of dimes gives me 16 total coins. And then I could solve this system of equations just like we've been doing by substitution or elimination to find out how many nickels and how many dimes I have. Let's take a look at example 1. Now in example 1, again, I've got kind of a money situation here. And notice my subscripts. So NN might represent the number of nickels, NQ might represent what? The number of quarters. And in the first equation, I know that I have 290 cents. So in other words, if I take the number of nickels times 5, that gives me how many cents in nickels I have. If I take the number of quarters times 25, that's how many cents in quarters I have. And those add up to 290 cents. Now the second equation, I know that the number of quarters is equal to the number of nickels plus 2. Now we're going to use substitution on this because really it's set up for substitution. I know what NQ is. NQ is equal to this. So what I'm going to do is I'm going to take that NN, or number of nickels, plus 2, and I'm going to substitute it into the other equation right there. So what I have then is 5NN, or number of nickels, plus 25 times whatever NQ is, and NQ is NN plus 2, and that equals 290. Now I solve it for NN, just like I would when we ended up with all x's in the equation. Well, here we're just solving for NN. So I have 5NN plus, let's see, 25 times NN is 25NN, plus 25 times 2 is 50, equals the 290. Right, 5NN plus 25NN is 30NN, plus the 50. Now I'm going to subtract 50 from both sides, and that gives me a 240. So 30NN is equal to 240. Now divide by 30. And that gives me 8. So what's NN mean? That's the number of nickels. So the number of nickels I have 8 nickels. Now let's figure out how many quarters I have. So I'm going to take 8 and I'm simply going to substitute it in right up here into this equation. So NQ, or the number of quarters I have, is equal to the number of nickels, which is 8, plus 2. So how many quarters do I have? I have 10. And these are pretty easy to check because I should be able to substitute 8 in for this, substitute 10 in for this, and do the multiplication there, and I better end up with 290 cents, and I would. So if I took 5 times 8, which is 40, plus 25 times 10, which is 250, and I see that 240 plus 250 gives me 290 cents. And I was able to solve for how many nickels and quarters I have. All right, one more example using elimination. Another money problem. Now on this one, I'm dealing with nickels and dimes. So my system of equations then is this, where I have a total of 135 cents, and I know that the total coins I have is 17. Now let's use elimination. So what could I do to, right now if I add the columns together, nothing eliminates. And I have plenty of opportunities here to cancel out one of the subscripts. I think what I'm going to do is I'm going to cancel out the NN. And you could as easily cancel out the ND. So I'm going to take the second equation and I'm going to multiply everything by a negative 5. That'll give me a negative 5NN in the second equation. So my first equation stays the same. So I have 5NN plus 10ND equals 135. I'm going to multiply everything in the second equation by a negative 5. So I have a negative 5NN plus a negative 5D, or in other words, minus 5ND, I should say, right? Because negative 5 times ND is a negative 5ND equals, now what's a negative 5 times 17? Let's see, 17 times 5, that gives me 85, and it's negative, right? Okay, now I'm going to add these two columns together. Put a plus sign there. So these cancel out. Let's see, 10 plus a negative 5 is 5ND equals 135 plus a negative 85 gives me, let's see, 135, the difference then. 13 minus 8, 50. Now divide by 5. So the number of dimes I have is what? 10. I have 10 dimes. Now, put 10 into one of these equations. Probably the easiest one is the second one because there's not as much work there. So put 10 in for the ND. So the number of nickels plus 10 equals or add up to 17. Now I'll write that a little more clear. So the number of nickels plus the number of dimes, which is 10, equals 17. Well, what number plus 10 is 17? Well, the number of nickels is 7. So I have 7 nickels, I have 10 dimes, and it's really easy to check these because you can just substitute the values into either one of those equations. So really not a lot different other than we're using a little bit more meaningful type of variables called subscripted variables.